So in exercise 2, creating line work for cutting windows, we'll look at the first technique that we're going to use in this video to build windows for our physical model. And that is by creating line work that we'll send to a laser cutter or a die cutter. So at the end of this lesson, we'll be able to understand what is not printable about windows, modify existing mullions for better line work and better fabrication, using orient to a view and model lines for off-axis objects. There are two methods for fabricating the finer detail window models in a project like this, and we're going to cover them in two different exercises. So the first exercise is going to be looking at a 2D cutting process, either die cutting or laser cutting, for the windows and the window mullions on this project. The first thing that we need to do and understand is that at a 1/16 inch scale, the default Revit mullions that are going to come in, these are 2.5 inches by 5 inches thick. So this 2.5 inches of width is going to be, well, basically it's going to be non-existent when we send it through to the laser cutter. Nothing is going to cut at all. Essentially, the mullion is going to be vapor. So the very first thing that we need to do in terms of working through the mullions, making them something that we can construct, is to increase the size of the mullions. And we want to do this globally on the model, and we want to do this temporarily. So the easiest method to do that is going to simply be select one of the mullions, and let's just simply increase its size. Now, one of the key things to remember with this is to go back and change it before you continue working, especially before you begin building final renderings, final elevations, that type of thing. But as a temporary fix, this is an easy method to begin the fabrication process for two-dimensional cutting. So I've got one mullion selected. I'm simply going to go to Edit Type. And my default size, which is 2.5 inches, I'm just going to increase that to 0.3 by 0.3. And this is going to build a mullion that projects out 3 inches on either side, or a 6-inch wide mullion. Now the corner mullions, this top edge, those I'm happy with the dimension already on all of those. Those should fabricate with the cutting process just fine. So the next thing that I'm going to do is open up this view, and let's just begin tracing some of these things out to get two-dimensional line work for our cutting devices. So on my south elevation, you can already see right here up top what we're beginning to work towards. I'm going to zoom in just so that I can work a little bit faster. Let's turn shadows off. And the method that I'm going to use is annotate and detail lines. Very quickly, I'm going to be able to select the rectangle tool, and I'm going to trace first out to out on everything that I want cut. And if you notice, I've built a specific line type called laser cut, and I'm using the default green color because I know our laser cutter, we use a universal laser, that is going to pick up that green line as a cut line, as a vector cut line. So very quickly I can trace through these windows. And if I have something that's really complicated, let's say it's a huge window or a very complicated pattern, my other option is that I could come through and export this as a DWG file and then import the DWG file back into Revit and simply use the line work from that DWG file to drive the cut pattern. What I've noticed, though, typically for our students that I've been teaching this method, this is tried and true, and it can usually happen very quickly, and it's also pretty easy to modify. So for the most part, this is a method I use until we reach a certain level of complexity. So what we want to do next is isolate this element. Oh, excuse me, not the element. Let's reset that. Select again. Let's isolate the category. And this will allow me to take that set of lines and move them up. And they are now ready to cut. And so you can see I actually have two versions of this window pattern right now. And any cutting device, either a die cutter or a laser cutter, is simply going to pick those up and begin running them. And if you notice, I've done this in my model. So this is at a 16th inch scale in terms of the representation, but this is also at 1:1. If I do a quick dimension out to out on these edges, you can see this is a 17-foot piece. Always work on these things at that 1:1 scale, because if I ever decide that my model needs to be at a 32nd of an inch, 1:20, 1/8, anything along those lines, I can simply change my scale here, resend the output, and I'm ready to go. So that was for a simple window, and I'm going to spare you doing all of the windows in this model. That would get really dull really fast just watching me trace some lines. But there's one other circumstance that can become a little bit tricky to work with, and that is when you have a window system that is a little bit out of plane and off axis, like this window right here that tilts out. So to do that, to build those lines, we're going to have to use a slightly different technique. So let me hide a few elements to get them out of our way. And I'm going to orient myself close to where I want to be, and then I'm going to use the view cube. I'm going to right click, orient to a plane, pick a plane, and I'm going to select one of these outer edges on the mullions. And it actually flipped me around, it oriented the plane correctly, but just the wrong side. Let's see if I can't get that. We'll try one more time. Sometimes this can be a little bit tricky. It will pick it up eventually. But I have a view already put together just in case this happened. So I'm going to go ahead and snap to that view. Have it called window view, and I used the exact same technique, and that was right click, orient to a plane. But every now and then, like I said, sometimes that can be a little bit tricky for Revit to snap you to the exact view that you want. So pre-built that view for us there really quick. Now if you notice, we're in 3D space now, and so the detail line tool isn't going to work in the same way, but we do have model lines. And using model lines, I can sketch exact same process, except the first thing that I need to do is set my work plane. So I'm going to set my work plane, again, as one of the outer edges of the mullions. I'm going to show that work plane just so we can see it right there. Let's turn that back off. And I'm going to use a really similar tracing technique. So I'm going to go Model Lines, Laser Cut Line, and I'm going to trace the outer edge across the system. And you can see I wanted to show this really quick. Every now and then we'll have something weird that happens in terms of understanding how a square is going to be represented in 3D space. So more often than not, going directly with the line tool is going to be the best method in terms of getting these pieces put together accurately. So let's zoom out and take a quick look. And you can see I've done something really terrible here. This is kind of exciting. As I was sketching that square in, something just didn't look right. You can see I don't have my work plane set correctly. Let's turn on show again. Yeah, so my work plane is actually in the wrong view. That's kind of a good mistake to show because it can happen really easily. Let's go back to this. So in other words, things looked like they were coming in correctly, but they were definitely oriented to the wrong view. So you can see things look right here, but weren't right at all in 3D space. So the lines actually weren't going to be what we wanted them to be at all. So let's go ahead. I'm going to isolate that category, delete them, and let's try this one more time. Reset. So I'm going to set my work plane, pick a plane. Let's make sure we get this outer edge here. There we go. Architecture, model lines. Let's see what happens if I use the square tool this time. Yeah, it's still a little bit off axis, but I can see I'm snapping to things now that I wanted to snap to where I wasn't beforehand. Much, much better. That should be exactly coming together as it should. So let's go ahead and I'll come in and do the interior edges of my mullions. And again, these are all mullions that I've upsized. So they're not the default 2.5 inches by 5 inches in depth. These are all now 6-inch wide mullions. Put together simply so that we have better cutting. And now let's go ahead and use a little bit of copying here. Copy, multiple. Let's slide this one into place. So again, I'm using the tab key to select everything with those lines. I'm using my copy to move them over to the next window pane. Again, the tab key to select all of the line works. Copy, multiple. Back to wireframe. Slide that in place. Now I'm almost done. Last piece. Copy. And there we have it. So what I need to do now is I need to get this line work grouped together with the other window so that I can send them all in one pass to a cutting system. So what I'm going to do, I'm going to select one of my lines, isolate the category. I'm going to select everything, and then we're simply going to use the cut command, because I'm going to want those deleted from that view. Again, 3D lines or the model lines are in 3D space, and I don't want to have to hide those every time I pull up a different view. So let's reset, and let's go over to that south elevation again. Now I'm going to use modify, paste from clipboard. And this should ask me for a reference plane. Or a lot of times this will ask for a reference plane. It's already referencing one of these exterior walls, so I'm in good shape. And I'm going to left click to place. Then I'm going to select all the lines. And because again, I don't want them showing up in 3D space as a model line, I'm simply going to use the convert lines. And now all of those are not model lines anymore, they're now annotation lines. So if I go to my 3D view, I don't have anything there. That has my windows ready to be set up in a particular view to send to the printer. Or not the printer actually, but a cutting system. So to do that, I'm going to crop my view. I want to isolate only the windows. And I'm going to build a new sheet. In this case, I'm going to be sending these to our laser cutter, which has a 24-inch by 18-inch bed. Let's rename this sheet to laser cutter and laser cutter. A little bit of redundancy, but that's okay. I'm going to take my south view already built that view apparently. Let's delete this sheet really quickly here. There we go, south view, place it onto the sheet. And now you can see those are ready to cut in the top left-hand corner of the laser cutter. And you can get a sense of the scale if this is a 24-inch by 18-inch laser bed, about how large these are going to cut out. Let's run a quick measurement. So that window, this piece is only 1 3/8 of an inch by, well, 45/64, so we're getting pretty ridiculous with our dimensions there. But what I wanted to point out primarily is each mullion at this scale, even with them being 6 inches wide, it's only a 32nd of an inch. So these are very, very small. In fact, I would say it's probably too small for a die cutter, but a laser cutter will handle that really well. Given the size of those pieces, though, there is one more method that I want to show in the next video, and that's doing something very similar, but utilizing the 3D printer to trace these out as printable mullion systems. The final laser cut models ended up looking something about like this that you can see in the image. It's a little bit too dark running the chipboard through the laser cutters to me. I didn't like the contrast in the model, so I went with the next method that I'm going to show you. But in this method, we did learn to acknowledge why printing windows in place usually doesn't work, how to modify window mullions to build better lines, and to create line work in an off-axis view by using model lines and orient to a view.